Very good morning to all. Uh, I welcome you all to the today's workshop, that is 2 days workshop on a study on sine table construction as described by ancient Indian mathematicians. So let me brief about this particular workshop before welcoming our chief guest who is going to inaugurate this particular workshop and our resource person also. This workshop aims to highlight the contribution of ancient Indian scholars in mathematics, specifically the scholars who introduced the formulas to construct Indian sine table. So, the Indian mathematics contribution, as you know, is well appreciated in the ancient days because of their immense contribution in trigonometry, calculus, and geometry. Surya, in pre-classical era, composed the traditional works called Siddhantas, known as Surya Siddhanta, focusing on construction of the sine table. So later Aryabhata came up with two methods for computing the trigonometric table. So later on, Bhaskaracharya improved it by giving the formula to calculate the sine value for each degree, and he called the method as Pratibhagika Jakavidhi. This 2 days workshop aims to study all these methods contributed by our ancient Indian mathematicians and illustrate those methods with examples. In this particular case, so we had requested, in order for this workshop to make it happen live, we requested our Professor Nadvin Mani NB from Gulbarga University, who is working as a professor of mathematics in the Department of Mathematics. So I wholeheartedly welcome you, sir, for this particular workshop. Right? I also welcome our resource person today, our Bhaskaracharya Study Chair Research Assistant, Sri Dr. Raj Shekhar, right? So who is going to elaborate on this particular method for 2 days, right? So I welcome you also, Raj Shekhar, for this particular workshop, and more importantly, I welcome our participants who are eager to know these particular methods, because as they are already aware with the traditional methods of calculating the sine values, so this is an opportunity to learn. Since this is the younger generation, you people need to know the contribution of Indian mathematics in regard to computation of sine table with different methods proposed by different Indian mathematicians. Right? So overall, I once again welcome you all, and I request Professor N.B. Nadvin Mani sir to give his welcome speech for this particular workshop. Over to you, sir.
Thank you, Professor. I am very happy to be a part of this inaugural function of the 2 days workshop on sine table construction as described by the ancient Indian mathematicians, to be held today and tomorrow, 25th and 26th of November 2020. So I immensely thank Professor Rajput and Dr. Chaudhary for giving me an opportunity to inaugurate this event of 2 days workshop. I really congratulate the coordinator of the Bhaskaracharya Study Chair, Professor Rajput, and also the convener of organizing secretary of this workshop, and Dr. Rajsekhar Chaudhary, who is a convener and also a resource person for this very meaningful workshop on the construction of sine table by the ancient Indian mathematicians. As you all know, that India has always been a land of philosophy and metaphysics than the land of materialism and scientific research. Unlike Greece and Arabia, ancient India could boast of a persons devoted to the advancement of mathematics as a science by itself. And there are few classical Indian books dealing with the pure mathematics also. So Indian mathematics is essentially practical and does not contain several watertight compartments such as geometry, algebra, arithmetic, and trigonometry, which have been developed in the later stage. And there is no such elaborate theory as Greek mathematics, while some theory that is occasionally given taken a practical form. Though the ancient India had always been given a sort of marginal attention to the study of mathematics at the particular Indian genius, with its marvelous gifts of intuition, was destined to the rest of the world. The important basic ideas in mathematics, namely the place value system of notation in arithmetic, the generalization of algebra, the sine function, and the trigonometry, and the foundations of indeterminate analysis are the important contributions given to the rest of the world by the ancient Indian mathematicians. The Indian mathematical works are, as a rule, written in verse and in the poetic lines, adds to the obscurity of the language. Besides, they are very brief, containing merely rules, results, and sometimes a number of problems with solutions. But very rarely, a fully worked out examples can also be found in their work. So Aryabhatta, who lived in the 5th century, he gave an important contribution as the alphabetic notation for the representation of numbers and their notation, involution, and evolution of the numbers. And there is a next general direction for determining the area of any figure by the decomposition into trapezia, one particular case of inscribing a circular polygon, hexagon with circle, as suggested by the results that the inside of regular hexagon is equal to the semicircle. So Aryabhata's sine table is one of the most ancient sine table constructed by Aryabhata. The astronomical treatise Aryabhatiya was composed during the 5th century by the Indian mathematician and astronomer Aryabhata, who lived in the year 476 to 550 Common Era or AD, for the computation of the half chord of certain set of arcs of a circle. And it is not a table in the modern sense of the mathematical table. That is, it is not a set of numbers arranged into rows and columns. Aryabhata's table is also not a set of values of the trigonometric sine functions in the conventional sense, and it is a table of the first differences of the values of trigonometric sines expressed in Archimedes, and because of this, the table is also referred to as Aryabhata's table of sine differences. And during these 2 days workshop, I hope the resource person may cover the computation of the sine table by Aryabhata and his computational method, substitution codes, and the concept of Ja and scope of the Jyotpatti, that is trigonometric Trigonometry Shastra. And also, he may cover the trigonometrical methods of trigonometric functions, their definitions, trigonometric tables, then addition and subtraction theorems for sine and cosine tables, and also you can cover the geometrical methods of construction of the sine table. So with these brief remarks, so I feel happy to say that the workshop is open for the discussion and the presentation by the resource. I congratulate the chair, Bhaskaracharya Study Chair of Akamadi Karnataka State Women's University, for taking up this important event and giving a knowledge of ancient Indian mathematicians' contributions in the importance of the study of trigonometry which is the original by itself and given to the rest of the world for the study of astronomy. So I thank you again, all the convener and the coordinator, for giving me an opportunity to be a part of this inaugural function. Thank you. Over to Professor Rajput.
Yeah, thank you very much, sir, for your welcome words to this particular workshop. Uh, uh, for the information of our participants, most of us are students of our department only, sir, Department of Mathematics,
Okay.
MSc third semester students, as well as we had invited our physics students also, since it is already related, very closely related in these sine table constructions, and to make aware them regarding the Indian mathematicians contribution and the today modern mathematics computation sine table, how they do, right? So for the participants, let me tell that Professor Nadin Mani is part of our Bhaskaracharya Study Chair advisory board, and he is constantly encouraging us in taking up various activities, and he is one of the key contributor in preparing PG diploma and certificate courses in Bhaskaracharya study, so which we are going to implement from the next year 2021 and 22 onwards, so for the benefit of our younger generation. So thank you very much, sir, Professor Nadin Mani, sir, for inaugurating this particular workshop and welcoming this particular workshop and permitting us to open the workshop.
Yeah.
Now I hand over the mic to our resource person, research assistant, Dr. Rajshekhar. So for continuing with his the methods of study with regard to sine table construction. So
Thank you, sir.
participants.
Please allow me to leave the mic.
Yeah. So sir,
Thank
you
you.
can leave now. I will hand
Thank
over the mic to Rajshekhar so that he can continue. Thank you.
Thank you very much, sir. I would like to thank Professor G.G. Rajput for welcoming today's guest, Dr. N.B. Nadivimani, sir, and who gave you the inaugural speech. Thank you, sir. Once again, on behalf of organizing committee and Karnataka State Akamadevi Women's University, I would like to thank you for accepting our invitation and delivering the impactful inaugural speech on the contributions of Indian mathematicians. Thank you, sir. Now we will move on to the first day topic entitled Introduction to Basic Terminologies and Construction of Sine Table using Surya Siddhanta method. Okay, before going into the topic, I would like to brief you about 2 days workshop. As already said by Professor G.G. Rajput, the 2 days workshop aims to highlight the contribution of ancient mathematicians in the field of trigonometry. Specifically, it focuses on the methods given by Surya, Aryabhatta and Bhaskaracharya for constructing the sine table. As mentioned in the brochure, we will be having 2 sessions. The first session emphasizes on the history of trigonometrical function, and the second session highlights the construction of sine table by using Aryabhatta and Bhaskaracharya methods. Now we'll quickly move on to the contents of today's presentation. So first, we'll be looking at the history of trigonometric functions. In that, we will see how these trigonometrical functions were defined, and we'll also see how the modern name sine came into force. In the second part, we will see the Indian definition of the sine function, which they called as ja. In the third part, we will also see how modern trigonometric functions were defined, and in the fourth section, we will be knowing the value of radius, which was considered by several scholars and has been used in most of the historical calculations. In the last section, we will learn to construct the sine table using the method proposed by Surya. So it was also known as a Surya Siddhanta rule. So coming back to the history of trigonometric function, the initial study on the construction of sine table, it began in 2nd millennium BC in Egyptian and Babylonian mathematics. In Hellenistic mathematics, these trigonometrical functions began reaching India as a part of Hellenistic astronomy. So this Hellenistic period is a period, it is the period between the death of the great Alexander in the year 323 BC and the emergence of Roman Empire. So that period is called as a Hellenistic period. So during the Hellenistic period, so this the construction of trigonometric tables, they started reaching India as a part of Hellenistic astronomy. So in India, so this the construction of trigonometric functions emerged, or you can say it took its place during the Gupta period because of the contribution of Aryabhatta, who constructed a sine table during that time. So several researchers, they started working on constructing these trigonometric tables. So at the same time, and the motivation for Indians to study this sine function came from they were interested in studying the motion of planets in the celestial bodies. So in order to do that, it was necessary to understand what is the sine function. So because of that, Indians started studying the construction of sine table, and simultaneously in Islamic geometry, the mathematicians such as Al-Khawarizmi and Abu al-Wafa, they started this trigonometry through the Middle Ages, and later they translated the Arabic text to the Greek text, which contributed to the acceptance of this trigonometry by whole world. And during this Western Enlightenment period, so these modern trigonometry changed, beginning with the 17th century by Isaac Newton and James Stirling, and it took its final form with Leonard Euler. And the name this trigonometry is derived from the Greek word, which means where this trigonon means a triangle and metron means a measure. So it is to do with a measure of triangles. Now coming back to the India, the most commonly used language in the ancient times was Sanskrit. So in Sanskrit, the Hindu word for this sign is ja, which means a bowstring. Apart from this, Indians also defined the other two trigonometrical functions such as Kotija and Utkarmaja. So where ja is nothing but a sine function, and Kotija is nothing but the cosine function, and Utkarmaja is nothing but the worst sine function. And the choice of this name Ja, Kotija and Utkarmaja is based on some significance which I will be discussing in the upcoming slides. So after Indians introduced these trigonometric functions, they got translated into Arabic in Baghdad in 8th century. The Sanskrit word, so Ja was also called as Jiva, itself was adopted as a technical term for the Indian sine function. So during the translation, they wrote it as Jib or Jaib, which does not have any meaningful word in Arabic. So during the translation, what happened is they wrote this Ja as Jib or Jab, which does not have any technical significance in the Arabic word. But after that, the most commonly used Arabic word was Jaib, that is a Jaib, which also means the bosom. So the Arabic word Jab and the Indian word Ja both means the same. No. And after that, further this particular Arabic text was being translated into Latin during the 12th century by the Latin translator, that is Gerardo and Ceremano, in the year 1150. He used the Latin word corresponding to Jab, that is a sinus, which literally means the same. So, which is also equivalent to the Arabic word Jab, and which is also equivalent to the Hindu word Ja. So that is sinus means a Ja, which in Arabic it is Jaib. So thus what happened is an Indian versional term, that is Ja or Jiva, after its long journey to the West Asian countries and European countries, it came back to India after several decades as a sign in the British rule. So this was regarding the history of sine function. So it all started in the 2nd millennium BC, and it started reaching India in the Hellenistic period, and after that it took its speech in Gupta period because of the construction of Aryabhata's table, and after that it has been translated to Arabic. From Arabic to it went to Latin. So in Latin it was named as a sinus, and after that it came back to India as a sine function. And Indians not only defined the sine function, apart from that they also defined the other two trigonometrical functions, which as a kotija. So this kotija is nothing but a koja. It is also called as koja, which is nothing but a cosine function. Okay, and the Sanskrit word this koti, which means amongst the others. So in general the word koti in Sanskrit means the amongst the others, or it is also called as extremity in general. Okay, and if you speak in terms of a trigonometrical thing, so it is a trigonometry. Hence in trigonometry it came to denote the complement of an arc of 90 degree. So the modern term cosine appears to be connected with kotija, for in Hindu works, particularly in the commentary of kotija is often abbreviated into koja. So when ja became a sine during the translation of Latin, so similarly this kotija becomes koti sine, that is koja became cosine. So that's how the name cosine came into force. And the other trigonometric function defined was utkarma ja, which in modern terms known as a worst sine. Okay. So utkarma ja is also known as worst sine, so which is equivalent to 1 minus cos theta. So in modern terms, so worst sine is equal to 1 minus cos theta. Now this utkarma means in Sanskrit it means a reversed or going out, or it is also sometimes expressed as an exceeding term. So we'll look at in the next slide why it is called as a reverse or exceeding term is called as a utkarmaja. Hence the name utkarmaja came into force for a worst sine. That is because utkarma means worst. So in modern terms we call it as a worst sine. So these are the three trigonometrical functions defined by Indian scholars. So one is, as I said, it is ja, which was also called as jiva by Indians. So when it went back to Latin, in Latin they called it as a sinus, which is after some translation it came back to sine in the British rule. And Indians also defined kotija or a koja, which is a cosine function, and they also defined the utkarmaja, which is the worst r sine function. Now we look at how the Indians defined this particular ja function, so which is also known as the Indian sine function. So just look at this particular figure number 1. So what we can see is we can see a circle of arbitrary radius r, right? So this figure 1, so we have a circle of arbitrary radius r. So let us take any arc AP whose length is alpha and which subtends at an angle theta to its center. So let us take an arc AP whose length is alpha and which is subtending at an angle theta to its center. So let us draw this PM. Let PM be the perpendicular from P on the radius OA, where OA is the radius of the circle. So let us draw PM be the perpendicular from P on the radius OA. So these Indians called this line PM as the ja, that is the sine function. So it was called as a sine function of an arc AP whose length is alpha. So if you look at the subfigure where I have written, it is mentioned that P dash AO, right? So this P dash AP, if you just look at this P dash AP along with this OA, so it just look like a bowstring with an arrow. So that is the reason the bowstring was called as ja in Sanskrit. So that is the reason Indians called this sine function as a ja. The reason is that, so it was looking like a bowstring with an arrow. So that is the reason the ja came into. Ja was the term which was used by the Indian scholars. No. So clearly from the figure, as I said, what we can clearly see is, if I look at the arc, AP is an arc of length alpha, and if I consider AP dash, one more arc, so the length of arc is equal to the arc of an AP, which is alpha. So together this PP dash is an arc whose length is 2 alpha, which is subtended at an angle 2 theta. Correct? So PP dash is an arc of length 2 alpha, which is subtended at an angle theta to its sun star. So since the Indian sine function, that is PM, is defined as the half the chord PP dash. So if you just look at the figure, so PP dash is a chord in the particular circle of arbitrary radius where PP dash is a chord. So half of that chord is PM, which is nothing but the Indian sine function. So Indians called it as the Ardha Ja. So Purna Ja means it is a chord, PP dash is called as a Purna Ja, and Ardha Ja means PM. So to avoid the confusion among the variables, so they called it as Ardha Ja. Ardha Ja means PM. Okay. So therefore, the Indian sine function of an arc in a circle was defined as the length of half the chord of twice the arc. See, AP is 1 arc, so the sine function is defined as half the chord. Right? Full chord is PP dash and half the chord is PM. So that PM is defined by the Ja. So so this is about regarding the sine function. Okay. So this is we can also see that the Ja of an arc AP, as I said, which is equal to chord PP dash by 2, and we know that AP is equal to alpha, which length of AP is alpha. So Ja alpha is equal to chord of 2 alpha by 2, because the length PP dash is equal to 2 alpha, so which is chord of 2 alpha by 2. So from figure 1, the Indians also defined the other two trigonometrical functions. So like as I said, Kotija and Utkarmaja. So the line Pn, which is equal to OM, right? So in the figure, what you can clearly see is Pn is also equal to OM. That was called as a cosine function by the Indians, and they named it as a Kotija. And they named it as a Kotija, and corresponding to the, and it is also called as this NP or a OM is also called as a sine function of a complementary arc BP. If I take an arc AP, so it is a cosine function with respect to the arc AP, and it is a sine function with respect to the arc BP. So the line NP equal to OM is a cosine function with respect to an arc AP. So it is also a sine function with respect to the corresponding arc, that is BP. And it is also the distance of P from the perpendicular reference line of BD. So this Pn is the distance of P from the perpendicular reference line BD. And we have one more term called as Utkarmaja, which was defined by Indians, that is MA. So which you can see in this figure 1. So this MA was called as Utkarmaja, which is nothing but the worst sign, and it is defined by OA minus OM. We know what is OA. OA is the radius of the circle, and we know what is OM. OM is the Kotija, which is a cosine function. So that is OA minus OM will give you the worst sine function. So this is so as I said, PM is a sine function, and NP equal to OM is a cosine function, and MA is the worst sine function. So now we will just quickly move on to the geometric form of modern trigonometrical functions. Okay. So what I have done here is this figure 2 is just a first quadrant of this previous circle, which was there in figure 1. If I just consider the first quadrant, that is OAPB, so I just took that first quadrant to explain the geometric form of modern trigonometrical functions. So what we can see is, let OAPB be a quadrant of the reference circle of radius r, and AP be an arc subtending at an angle theta at its center. And let the line OP, let us take point A. At point A, let us draw a tangent, and let us draw one more tangent at point B, and let the line OP, when extended, it cuts the tangent A at T, and it cuts the tangent B at the point Z. Then the line OT is called as the secant line of an arc AP, and OZ as a secant line of the arc BP. So then from the definition of this trigonometric function, so in the right angle triangle OMP, the sine function is defined as PM by OP is equal to sine theta, and OM by OP is equal to cos theta, and similarly PM by OM is equal to tan theta, and OP by PM equal to secant theta, and OM by PM equal to cot theta, and OP by PM equal to cosecant theta. This is how the modern trigonometric functions were defined as the ratio of right angle triangles. So when we compare both the methods of defining the trigonometric functions, the ancient definition was based on the length of an arc has an more advantage over the modern definition in one particular case, that is to show that, let us consider the case of angle theta equal to 90 degree. So if I take angle theta equal to 90 degree, the modern sine and cosine can only be defined as a limiting case, because when the degree is equal to 90 degree, I cannot form a right angle triangle. The modern trigonometrical functions were defined based on the right angle triangle, the ratio of right angle triangle. But when at 90 degree I cannot form a triangle, then it becomes a very tough job for me to define the sine or a cosine function when theta is equal to 90 degree. For that reason, we go for a limiting case approach. But this was not the case in the ancient. So as you can see in this figure, what you can see is, as I said, where PM is a sine function, for an angle theta equal to 90 degree, what happens? That is arc is AB. Okay, so let us take arc AB equal to alpha. So it is very simple that the sine function is equivalent to OB, which is equal to radius. So from clearly we can see that if you measure it in terms of a length based on the ancient methods at 90 degree, theta equal to 90 degree, so this OP becomes OB, so which is the sine function, and this OM will not be there because it becomes a 0, so that is a cosine function, and this MA which is there, so which is equivalent to radius again. So these three functions can be easily measured if you measure by the length, but it is very difficult in the modern methods because here we are depending on the right angle triangle, but at 90 degree you cannot form a right angle triangle, therefore we go for a limiting case approach. And the one disadvantage of the ancient trigonometric function is that they vary with the radius of the reference circle chosen. So if the reference circle is equal to 1, then we won't have any problems. But if the radius of the reference circle is not equal to 1, so then we may come across some problem. Now we will move on to the radius of the reference circle, which is also known as sinus totus. Okay. So these Indians used a variety of values in the ancient as well as in the medieval periods of their trigonometry, and the most typical value of sinus totus were obtained from the following relation. So it is a just relation of circumference, C is equal to 2 pi r. If I rewrite it in terms of r, I will be getting r is equal to C by 2 pi r. So where C is the circumference of the circle, and it is a linear quantity and should be defined in linear units. But the Indians took an angular measure of the circumference itself to represent this linear measure. So they took ja is equal to r sin theta, which are already defined. So this is nothing but cot 2 alpha by 2. Okay. So the angular measure, this alpha chosen by the Indians, is exactly equal to the angle theta. And to calculate the value of r, we need to know the value of phi. So it was the value of pi, the approximation to phi was given by Aryabhatta, who gave the approximation to pi as phi is equal to 62832 divided by 20,000, which comes up to be 3.1416. So it was an approximation given by the Aryabhatta. So we are making use of this particular approximation, and we have substituted the value of this pi in the equation 1. And where we need to take the value of C, as we said, we have Indians measured it in terms of angle, so we are taking the circumference equal to 360 degree. So if we just substitute the values 360 by 2, which is multiplied by pi, so what we are going to get is, we are going to get 75,000 divided by 1309 degrees. So So this is the value of radius which was considered by the Indians. So this value of radius can be converted to minutes, seconds and thirds. So we'll just see how to convert this value in terms of degrees, seconds and thirds. So let us take this first value. So that is R is equal to 75,1309. So on simplifying, what I will get? I will be getting 57 degrees plus 387 by 1309. So what we need to do is we just need to divide this 75,000 divided by 1309 and note down the value before the point and keep the remainder as it is. So I will be getting something like 57 point something, and the remainder I am getting is 387. So that is 57 plus 387 by 1309. So here 57 is in terms of degrees and 387 by 1309. So this is in terms of degrees. If I want to convert it into in terms of minutes, I need to multiply this R by 60 in the numerator. That is 75,000 is multiplied by 60 divided by 1309. So which comes out to be equal to 3437 plus 967 divided by 1309 minutes. Okay. So this is again the same procedure is applied. So just divide that 4,550 zeros divided by 1309. So what you will be getting is you will be getting 3437 plus the remainder as 967, which is divided by 1309 minutes. So if you want to convert it into in terms of seconds, so what I have to do is I have to again multiply the equation number 6 by again 60 in the numerator. So what I will be getting is 20,624 plus 424 by 1309 seconds. So if I further simplify this, I will be getting 3437 minutes and 44 seconds. If I still go on reducing this in terms of thirds, so what I will be getting is 75,000 multiplied by 60 3 times, which is divided by 1309, which on further simplification, the final value which I am getting for R is 3437 minutes, 44 seconds and 19 thirds. And if you look at the relation 6, so what it says 3437 plus some minutes. So that is the reason the Indians are most commonly used this particular value. So they round it to 3438, so which was the value of R, which was considered by most of the Indians in order to calculate the sine values. So far what we have learned is we have learned the history of sine function and how the Indians defined ja, kotija and utkarmaja, and we also learned how the modern trigonometrical functions were defined, and at last we also learned how the ancient scholars defined this the value of R, which is equal to 3438. So now we will move on to the construction of the sine table using the very first known Hindu method, that is Surya Siddhanta rule. So the Surya Siddhanta is as I said, it is the earliest known Hindu work which provides a table of trigonometric functions wherein it provides the table of trigonometric functions wherein the Surya gave the sine value for an arc of every 3 degree 45 minutes of a circle of radius 3438 minutes. So according to the Surya, the first R sine is the 1 by 96th part of a circle. So if you take the 96th part of a 3438 radius, you will be getting 225 minutes. Okay. And the second R sine is given by the remainder added with the first R sine, the remainder added to the discrepancy that R sine, and the previous R sine would provide the next R sine. So which I will be explaining in the formula itself. So words are somewhat tricky. So what it says is the second R sine is given by the remainder added with the first R sine. So the first R sine is 225. So you obtain second R sine by adding the remainder with the first R sine and the remainder added to the discrepancy. So this process continues if you go on finding the values, first, second R sine, third R sine, so on up to 24 R sines in a quadrant. So the general formula for generating the 24 R sine in a quadrant is given by the formula. So which says ja of n plus 1 h is equal to ja nh minus ja of n minus 1 of h plus ja of nh minus j of nh divided by 225. This 225 is nothing but the first r sine value, where this n takes the value from 1 to 23. So if you go on substituting the values for n, so you will be getting the successive r sine values. So as I said, the Indian used the length function. So the length is h, which is also equivalent to the angle theta. So if I replace h by theta, and we know that j is a r sine function, so what I'll be getting is, in place of j I have a r sine n plus 1, in place of h I'll be having a theta. So that is r sine of n theta minus r sine of n minus 1 theta plus r sine n theta minus r sine n theta divided by 225. So if I take the radius as 1 unit, so the above equation, which is in number 2, reduces to the following form, that is sine of n plus 1 theta is equal to sine n theta minus sine of n minus 1 theta plus sine of n theta minus sine n theta divided by 225. Okay. So what we'll do is we'll make use of the formula which is given in the equation number 3. So what we'll do is let us substitute for the first case. We already know the first r sine value is 225, that is, it is 1 by 96th part of a radius, that is 3438. 1 by 96th part of a 3438 is equal to 225, which is the first r sine value. So to find out the second r sine value, so we'll substitute n equal to 1 in this relation. So what we get, let us see. So substitute n equal to 1, so it becomes sine of 1 plus 1. So theta is, as I said, it is 1 by 96th part, so that is 3 degree 45 minutes. So 3 degrees 45 minutes is equal to 225, that is because 3 degrees, so if I convert it into minutes, I have to multiply it by 60. So 3 degree into 60, it becomes 180. So we have 45 minutes addition, so 180 plus 45. So together it comes up to be 225 minutes. So substitute the value of n equal to 1, that is sine of 1 plus 1 into 3 degree 45 minutes, which is equal to sine of n is 1 and theta is equal to 3 degree 45 minutes, minus that term will become 0 because sine of 1 minus 1, that is sine 0 is 0. So that particular, the second term will not come into the picture. And the second one more we have is sine n theta, that is sine again 3 degree 45 minutes minus sine 3 degree 45 minutes divided by 225. So if I simplify, so what happens is sine of 7 degree 30 minutes. So that is 2 into 3 degree 45 minutes. It is not a usual multiplication. You have to convert it into degrees. So 3 degree 45 minutes, if I add it once again, so it becomes 6 degrees 90 minutes. So from that 90 minutes, I will subtract the 60 minutes which contribute to 1 degree. So that adds to 1 more degree. That 6 becomes 7 degree 30 minutes. So this is how we need to multiply. Okay, so that is sine 7 degree 30 minutes is equal to, we already know what is sine 3 degree 45 minutes, which is 225, plus just substitute the value of sine 3 degree 45 minutes, and after simplification we will be getting 449. So this is how we are going to obtain the r sine values. So in the same way, we are supposed to find out the remaining r sine values. So just by substituting n is equal to, we have already, as I already shown you how to calculate the r sine value when n is equal to 1. So you can similarly do it for 2, 3, so on up to 23, so that you can get the r sine values for the 24 r sine values. The advantage of this method is, so in ancient methods, even now also, we people are knowing the values of sine function for 30 degrees, 45 degrees, 60 degrees and 90 degrees. So if somebody asks us to find out what is sine 30 or sine say sine 10 degree, so we don't know how to calculate that. We need a calculator. But in those days, the Indian scholars used to find out the sine function of any degree, so which is explained by Bhaskaracharya, which I will be explaining tomorrow. So this is about the Surya Siddhanta rule, and what we can do is next is we have the remarks made by the D.L. Burns on the Surya Siddhanta method, wherein he says the method is curious and it indicates a method of calculating the table of r sine by means of their second differences. And the Indians he also says that the Indians also have probably done the same, and they received the method of differences only from the table calculated previously by the geometric process. He adds on and says that here then is a method that Indians possessed, which is found neither amongst the Greeks nor amongst the works. So these were the remarks made by D. Albums on the Surya Siddhanta method. So this completes the lecture of day 1, and so we'll have an assignment is that to construct the sine table containing 24 values using the Surya Siddhanta rule. So as I said during the calculation, so here I have done it for n is equal to 1. So n equal to 1 is that is sine 7 degree 30 minutes, which is 449. So similarly you are supposed to calculate it for remaining 22 values. So sorry, remaining 22 values. So that we will be having a list of 24 r sine values. So you are supposed to submit that assignment work. Okay. So you are supposed to submit this assignment. So after the session, all the registered participants will receive a feedback form to your registered email ID. You are supposed to fill the feedback form and submit the assignment by email. And please note that those who submit both feedback and assignment work will be issued e-certificate after receiving both from day 1 and day 2. And these are the references which I have used for my lecture from day 1 and day 2. So majority of the content has been taken from a textbook written by Venugopala Herur, which is the textbook entitled as a Bharatiya Trigonometry Shastra, which was published by Manipal Press. So it is an excellent book which highlights the contribution of ancient Indian scholars in the field of trigonometry. If you are interested in the history of trigonometric functions, so this book will provide you all the information based on all the information regarding the history of sine function, cosine function, tangent function, and history of most of the trigonometrical functions. And this book is available in Amazon. If anybody interested can purchase this particular from the Amazon website. Now we'll just quickly move on to the questions. If participants have any questions, let us take that. And as I already received a couple of questions from the participants, okay. So we have received the 2 questions from the participants. So the first question is asked by Shruti. What the other values chosen for R apart from 3438? As I said, most commonly used value of R is 3438. The other values are 3270, which was used by Brahmagupta. He considered the value of R to be equal to 3270. And Madhava, he considered the value 3437 minutes, 44 seconds and 48 thirds. So he considered that particular value for constructing the sine table. And most majority of the people like Aryabhata, Surya, Bhaskaracharya 1 and Bhaskaracharya 2 and Aryabhata 2, most of them have considered the value of R is equal to 3438. And the procedure of getting the value of R, which I already explained in the previous slides. And we have one more question asked by Swati Karanth. Why Surya Siddhanta method gives the R sine value for 3 degree 45 minutes? Okay. So in those days, all these calculations were done manually. Okay. So a human eye can only recognize 96 parts in a circle. Beyond that, it is very difficult for a human eye to recognize those parts distinguishedly. Okay. So that is the reason. So they restricted, and they also found that the 1/96th part of a circle is 225 minutes, and its R sine value is also equal to 225. So that is the reason they did not go beyond that. So what they have done is they have taken a circle and divided into 96 parts. So in each part you will be getting 24 parts. So that 1/24th part is nothing but the 225. 1 by 24th part is the 225 minutes, and which corresponds to 3 degree 45 minutes. So that is the reason they have constructed for 3 degree 45 minutes. So in the tomorrow lecture, we will also see construction of sine table for every 3 degree, and we will also see the construction of sine table for every degree proposed by Bhaskaracharya. I think I have only received 2 questions from the participants. If you still have any queries at any point of time, so you may feel free to contact at this below address. So you can also subscribe the Bhaskaracharya Study Chair YouTube channel for the various programs organized by the chair, and you will also be getting the notification of new programs organized by the chair. So with this, we will end the today's session, and we will meet tomorrow with the second lecture on the construction of sine table using Aryabhatta and Bhaskaracharya method at 11 am. So the link for attending the day 2 session will be mailed to you shortly along with your feedback form. Thank you.